our integrals. Of the form, the integral of a sec to the power of n of x dx, and the integral of cosec n of x dx. Okay, so when working this out, we look at the two cases when n is even and when n is odd. So if n is even, then we use the identities that tan squared x is equal to sec squared x minus 1, and also that cot squared x is equal to cosec squared x minus 1. Then if n is odd, we will still have to break it down a little bit, but eventually we will have to apply integration by parts. Okay, so we look at some examples which are not that different from how we've been solving the others so far. When we have the integral of a sec to the power of 4 of x dx. So this one, what we do is we can rewrite it as sec squared x times sec squared x. So this is the integral of a sec squared x times a sec squared x dx. And then one of the sec squared x's we can rewrite in terms of tan. So this is the integral of 1 plus tan squared x dx. From here, we would multiply out our brackets. We have a sec squared x plus tan squared x sec squared x dx. And then everything here is pretty simple and easy to integrate. So when we integrate sec squared, we get tan x, because the derivative of tan x is sec squared. And then this tan squared sec squared x. So this sec squared x is the derivative of tan x. So the integral of tan squared x sec squared x is tan to the power of 3 of x divided by 3. And then we add our constant of integration. So we have the integral of cosec to the power of 6 of x dx. So again here we would break this down. What we want to have is cosec squared multiplying by something, because cosec squared is the derivative of cot. So we can write this as the integral of cosec squared x squared times cosec squared x dx. Okay, then this cosec squared x inside the brackets, we write it down in terms of tan squared x. So this is the integral of 1 plus tan squared x, not tan, cot squared x squared times cosec squared x dx. So we would multiply out this bracket, we square it, and then multiply that with cosec squared x, and that will give us the integral of 1 plus 2 cot squared x plus cot to the power of 4 of x, and this has to be multiplied by cosec squared x dx. So now we can multiply out our brackets. This is the integral of cosec squared x plus 2 cot squared x cosec squared x plus cot to the power of 4 of x with cosec squared x, and this is all with respect to x. Okay, then from here, everything is easy to integrate. The integral of cosec squared is negative cot. And then the integral of this one here, the derivative of cot is cosec squared, or negative cosec squared. So this is the derivative of that. So we would just have 2, and then we raise the power over here to 3, and then also divide by 3. So we have 2, cot should be negative, cot to the power of 3 of x over 3. And then the same thing with the other one, comes negative cot to the power of 5 of x divided by 5. Then we add our constant of integration. Okay, so that's when we have an even numbered power. Now with an odd numbered power, we would do it slightly different, but we would have to use integration by parts. So let's say we want to integrate sec to the power of 3 of x dx. So this one we can rewrite as sec squared of x times sec of x dx. Then we want to use integration by parts, so we need to pick our u and our dv. So u is going to be sec x, and then dv is sec squared x dx. Then that means that du here is the derivative of sec x is just sec x tan x dx. And here when we integrate sec squared x, we get tan x. Tan x. Okay, so we have everything we need in order to integrate by parts. So this is u times v, so it's sec x tan x, and then subtract v times du. So you'll have sec x times tan squared of x dx. Okay, then to integrate this, our tan squared, we can now rewrite it in terms of sec squared. So this is sec x tan x minus the integral of sec x times sec squared x minus 1 dx. And this gives us sec x tan x minus the integral of sec to the power of 3 of x minus the integral, there's a dx here, minus the integral of sec x dx. So you can see here I have sec cubed of x, and that is what I was trying to integrate. So I have one on the left-hand side and another one on the right-hand side. So I can take this one here to the other side. Then I will have 2, the integral of sec cubed x dx. This is equal to sec x tan x minus the integral of sec x dx. And then we would divide everything by 2 because we only want the integral of sec cubed x dx. So this is a half sec x tan x, and then the integral of, the integral of sec x, we said, is ln of sec x plus tan x. So this is ln of sec x plus tan x. So we've shown that several times, and then you add your constant of integration. And number 4, we have the integral of cosec cubed x dx. So this one, we would solve it in pretty much the same way that we did sec cubed of x. We would write it as sec squared of x times sec x, and then from there we would use by parts to integrate. So we said this we must write as cosec squared x times cosec x dx. Then we pick a u, which is cosec x, and then dv is cosec squared of x dx. Okay, differentiate u, get du is equal to the derivative of cosec x is minus cosec x cot x dx. And here, if we have dv is cosec squared of x, this means that v is negative cot of x. Okay, so we have our terms needed for the integration by parts. So this is u times v, so it's minus cosec x cot x minus the integral of v times du. You can see that v is negative, du is negative, so negative and negative will give me a positive term. And I have cosec x cot squared x dx. And then cot squared x, I write it in terms of cosec squared x. So this is minus cosec x cot x minus the integral of cosec x, and cot is cosec squared minus 1 dx, which is minus cosec x cot x minus the integral of cosec cubed x dx minus the integral of cosec x dx. Now you can see I have cosec cubed. I'm integrating cosec cubed of x on both sides, so I can collect them on one side, and then I have 2 times the integral of cosec cubed x dx. This is equal to minus cosec x cot x minus the integral of cosec x dx. So the integral of cosec cubed x dx, this is a half minus cosec x cot x, and then we know that the integral of cosec x is just ln of cosec x cot x, negative that. So it's negative ln of cosec x plus cot x. So that negative will multiply with this negative here, and then we will get positive. I do that right. Oh, okay, I see what I did wrong here. This term here, when the negative, when the negative here multiplies with this negative there, this one here should be positive. So this should be positive here, and this is positive. And now the integral is negative ln of cosec x plus cot x, and then we add our constant of integration. We look at some of the questions from exercise 4.4. Exercise 4.4. We start with number 31. We have the integral of cosec to the power of 4 of x over 2 dx. So here our power is even. So what we need to do is write it as cosec squared x over 2 times cosec squared x over 2. So this is the integral cosec squared x over 2 cosec squared x over 2 dx. And then one of the cosec squared x over 2, we then rewrite in terms of cot squared. So this is the integral of cosec squared is 1 plus cot squared x over 2 times cosec squared x over 2 dx. Then we can multiply out our brackets. This is the integral of cosec squared x over 2 plus cosec squared x over 2 times cot squared x over 2 dx. And now everything is easy to integrate. The first one, cosec squared x over 2, the integral of that is just negative cot of x over 2, and then we divide by the derivative of x over 2, which is dividing by a half. That's the same as multiplying by 2. So for the first one, we get negative 2 cot x over 2. And then for the second one, we can see that we have a function and its derivative. So we have cot here. The derivative of cot is cosec squared. So the power of cot should go up by 1. So we get cot to the power of 3 divided by 3. And then we also divide by a half, which is multiplying by 2. So we're then multiplying by 2 over 3 and negative as well. So it's negative 2 over 3. We have cot to the power of 3 of x over 2. And then we add our constant of integration. Number 32, we have the integral of sec to the power of 4 of 2x dx. So again here, our exponent is even. So we will break it down as sec squared of 2x times sec squared of 2x, which is the integral of sec 2x of 2x dx. And then one of the sec squareds we have to rewrite as 10 squared plus 1. So this is the integral 2x plus 1 squared of 2x dx. This is the integral of 10 squared 2x sec squared 2x, and then we add sec squared 2x dx. Okay, so again, this is pretty simple to integrate. We know the integral of sec squared is 10. We will just have to divide by 2. And then the same thing over here, the derivative of 10 is sec squared. So the power of 10 here is going to go up by 1 to give us 3. And then we divide by 3 and then also divide by the derivative of 2x, which is 2. So we'll be dividing by 6. So this is 10 cubed of 2x divided by 6 And then we have tan of 2x divided by 2, and then you add your constant of integration. Number 33, the integral of cosec to the power of 6 of x dx. See, is this different from the example? It's exactly the same. Okay, you can skip that one. Number 34, the integral of sec cubed of ax dx. So here we have odd power, so we will have to use integration by parts. So we say we rewrite this as the integral of a sec squared ax sec ax dx, and then we pick our u, which is sec ax, and that means that du is sec ax tan ax, and then we multiply this by a. So if I just write this nicely, so we have a sec ax tan ax dx, and then our dv is going to be sec squared ax dx here. Negative 10. Why is it negative? Only the derivative of the trig ratios that start with c are negative. So the derivative of sec is positive. Okay, so we have du there, then v. This is, we have to integrate sec squared ax. The integral of sec squared of ax is tan of ax, and then we just divide by a. So we have tan of ax divided by a, or just 1 over a tan ax. Okay, so now we have our u, dv, du, and v. We just need to plug them into the formula for dv, du, in the formula for integration by parts. So we have the integral is u times v. So that's 1 over a sec ax tan ax. We have 1 over a sec ax tan ax, and then we subtract v times du. So v times du is this one here. The v times du, so you can see one a is in the denominator, the other a is in the numerator. They will cancel each other out, and then I just have sec ax tan squared ax. That's the integral of sec v sec cubed ax, actually, multiplied by, what am I doing now? Let me just see what I did. This was to the power of 3 sec squared okay, I think we're fine. Okay, minus sec cubed of ax. So sec cubed, that's v times du. No, it's not sec, it's just sec tan squared. Okay, then here again, I have to use by parts. I think there was an easier way to do it. Let's see, we have v times du tan squared and then sec. Okay, so here for this one over here, to integrate that, let me just do it in red here. Integral of sec ax tan squared of ax dx, we have to use by parts. So u is going to be tan ax and du is sec squared. There'll be an a outside. Sec squared of ax dx, and then our dv is sec x tan x. And then this means our v, this is a dx here, and that means our v is sec, let me write it nicely. So this means that dv is sec ax tan ax dx, and then our v now is 1 over a sec ax. Oh, a long one. Okay, so integrating by parts, I will have u times v. So I have, I see I'm just going back in circles. Yeah, because that will cancel with that one. See, what I need to do is from the beginning is substitute. Before I use by parts, I need to substitute, otherwise I'm back at sec cubed of ax is equal to sec, the integral of that. So here, sorry, what we should do before we do all this is this sec squared, we must rewrite it in terms of tan. So this is the integral of 1 plus tan squared ax, and then sec ax dx, and then this is the integral of sec ax plus the integral of sec ax 10 squared ax dx. Okay, now we can use by parts like I was doing in red over here. So the integral of sec ax, that one is easy because it's just 1 over a times ln of sec ax plus tan ax. And then this one here, the integral of sec ax tan squared of ax is the one that we are now supposed to use by parts. So this part can go. And then this part here, just shift it up. Okay, so we have sec ax tan squared ax. Then the integral will be u times v minus v du, and then from there we will get sec to the power of 3 of ax, which we can bring to the other side. So what we have is the integral of sec ax, which is 1 over a ln of sec ax plus tan ax, and then the integral of this one here in red, sec ax tan squared ax, is v times u. So plus, is this a plus here? Yeah, plus u times v. So that's 1 over a sec ax tan ax, and then minus the integral of v times du. So v times du, here's my mouse. Okay, v times du, the a and the 1 over a will cancel, and then I have the integral of sec cubed ax, which is the same as what we were given to integrate, minus sec to the power of 3 of ax dx. Okay, then this side, sec cubed of ax, we take it to the other side. So we will have 2 the integral of sec to the power of 3 of ax du, 1 over n of sec ax, is an x, and then plus a sec ax tan ax, and then we divide everything by 2. So the integral of sec to the power of 3 of ax dx, this is 1 over 2a, this whole thing in brackets, ln of sec ax plus tan ax plus sec ax tan ax, and then we add our constant of integration. Okay, so may seem a little bit tricky, but I think eventually it's not that long. Okay, so number 35, you can do that one on your own, and that is the first part of integration that involves trigonometric integrals. The next part, we look at the T formula, still on integration, but it's a different technique that we use when we are integrating. Okay, so we'll stop here for today, and tomorrow we continue at 9:30.